Good afternoon, everyone. I, Bhavya Besre, on behalf of my team, would like to present a gracious welcome to all of you on today's second session of Faculty Development Program. I'm extremely privileged to welcome Dr. Pravesh Shukla, who is currently working as an assistant professor in the Department of Mechanical Engineering at IIT Bhilai. He has done his BE from Pandit Ravi Shankar Shukla University, Raipur, MTech and PhD from Indian Institute of Technology, Kanpur. I would like to express my gratitude to you, sir. Pravesh Shukla, sir, has always lent his helping hand to our institution and gave his precious time to every invitation. Your presence matters a lot, sir, and we are elated to have you again with us for this faculty development program. He is also a published author of many research papers and has won multiple awards, most notably the Young Scientist Award in the year 2008, Environment and Sustainability. He also was a postdoctoral researcher in the Division of Combustion Engine, Department of Energy Sciences, Sweden University. Dr. Shukla mainly works in the field of he worked on the development of additives for high compression ratio, heavy duty engine fueled with alcohol. Till now, he has published more than 28 technical articles in international journals and conference proceedings. And now, sir, I request you to join us on the screen.
Hello. Yeah. Hello, this is Pravesh Shukla. So I will share the screen of my presentation.
Yes, sir. Good afternoon, sir.
Hello, good afternoon. So thank you for the nice introduction. I will start with my presentation then. Can you see the screen?
Yes, sir. Yes, sir.
Okay. I would like to, since this is a FDP lecture, so I wanted to brief about what are the advances in the IC engine emission and in the biofuel also. Basically, I'm assistant professor in the Department of Mechanical Engineering, IIT Bhilai, and I'm working here for last 3 years. I So if we begin with the automotive technology, so there are many pioneers. So like Wilhelm Maybach, Otto, Mr. Otto, then Benz, Carl Benz, Daimler, Ford, Diesel. So they have worked in different aspects of this automotive technology. Some of them have achieved reputation for the fuel injection system. Some of them have achieved the reputation for auto engine and diesel engines. So the evolution of automobile. Just hold a minute because there is some echo coming in my side. So since the late 1800s, 18th century, the technology came in the sector of automobile. Okay, so mobility was one of the major challenge at that time. And prior to the automobile engine, steam engines were famous. Okay, so the problem with the steam engine is that their efficiency is very low. At that time, the steam engine served at 15% to 20% efficiency, and also the steam engines are very bulky. So when you have to install the steam engine on the vehicle becomes very big. So this was one of the major advantage with automotive technology that they were very compact and the energy density was very high, because in the steam engine you need to carry coal, and coal is not very comfortable fuel. It is solid fuel, and also the energy density is low. However, in case of liquid fuels like gasoline or diesel, the energy density is very high, and since these fuels are liquid, these are easily manageable through the fuel injection system and other things. Uh, so fuels. So before begin with the main IC engine topic, first I would like to brief about what is fuel basically and why different technology of automobile engines come into picture. Okay, so fuel is basically fuel consists some chemical energy. Inherently, it consists some chemical energy, and this chemical energy, as a result of some exothermic reaction, this chemical energy basically converts into thermal energy of the gases, and then finally that thermal energy converts into mechanical energy of the piston. So there are so whatever fuels we are having, gaseous, liquid, solid. Okay, fuels are mostly hydrocarbons. Okay, if you observe any type of fuel, these are mostly hydrocarbon with some impurities. Okay, so if I say C1, C2, C3, C4 means C1 means CH4. C2, when I write C2 here, so this is C2H6. So likewise, the fuel consists different fuel consist different group of these compounds, different group of these hydrocarbons. Okay, for example. What is C? What when it is mixture of C1 and C2? This is normally known as natural gas. Okay, which is available from the crude wells, and this is also known as compressed natural gas. When we compress this gas C1 plus C2, then this is known as CNG, compressed natural gas. And LNG, when we further compress it and liquefy the gases, okay, this is known as LNG. Okay, so we do this compression because of the ease of the transportation, basically. And C3 and C4 is primarily known as liquid petroleum gas. So C3 and C4 are easier to compress. Basically, it consumes less amount of energy to convert into liquid form. And this C3 and C4 is popularly known as LPG, liquid petroleum gas, what we use at our houses. Okay, and then gasoline. What is gasoline? So gasoline is basically the mixture of C5 to C12. Okay, so whatever liquid components are there from the hydrocarbon, okay, this low molecular weight liquid component, these are basically the mixture. Gasoline is basically mixture of this C5 to C12, and majority of this gasoline consists of C7 and C8. Similarly, diesel and kerosene is the mixture of C10 and beyond. Okay. However, the centroid, the maximum portion of the diesel consists C12, and for kerosene it consists C10. So, in nutshell, I wanted to explain by this slide is that this gasoline and diesel, these are not one single hydrocarbon. Okay, these fuels are basically mixture of several different hydrocarbons. Okay, so it means these will not have a single boiling point. Okay, they are having a varying boiling point depending on the composition. Okay, so if somebody is producing this gasoline from the oil well in India, okay, so it means they may have some different composition. If you are importing this gasoline from Saudi Arabia, so that gasoline may have some different component. Okay, different composition. So it is like that. So their boiling point, and there is no boiling point for diesel and gasoline. It is basically the boiling range, which varies depending on the composition of the compounds. Okay, now I will quickly come to the diesel and gasoline engine. Most of you, I hope that most of you already gone through it, diesel and gasoline engine combustion. Okay, so why these two different engines come into picture? Okay, why can't we use just one engine, diesel or gasoline? Okay, why we need two different types of engines? So this is mainly because of the different types of fuel. Since gasoline has two very important property. Okay, one is the vaporization characteristics. So gasoline vaporizes very easily, and also its auto-ignition temperature is higher. For diesel, on the other hand, diesel is having very poor very poor vaporization characteristics, and its auto-ignition temperature is lower. And therefore, for gasoline fuel, it is very easily mixed with the air. And therefore we observe normally in the gasoline engine the fuel air mixture preparation happens outside the combustion chamber, and in diesel engine the fuel air mixture happens inside the combustion chamber. This is mainly because of the property of the fuel, inherent property of the fuel. So that was the main reason. Okay, that is the main reason for adopting these two different technologies. Okay, so when we call compression ignition engine and when we call spark ignition engine, so it is not like we have derived two different type of engine. We have in the past the two different engines were invented. It is not like that. These two different types of engine came into picture because of the different properties of the fuel. Because if you want to have combustion for the gasoline fuel, you need to have the spark ignition technology. If you want to have the combustion in diesel engine, then you have to have the compression ignition technology. So that is the prime reason. Okay, some of the basic feature related to gasoline engine is that the flame propagation phenomena. So the mixture in the gasoline engine prepares outside the combustion chamber, and the charge, when I say charge, it means the mixture of the fuel and air. It enters into the combustion chamber, and then the combustion happens because of the spark plug. So in the second diagram, you can see that there is a flame propagating towards the piston in a semicircular manner. Okay, semi-spherical manner. Okay, so this basically shows the flame propagation, that the flame starts from the point where the ignition happened, that is the spark plug, and the flame is actually propagating from spark plug towards the piston. So that phenomena is called the flame propagation. Okay, in opposite to that in diesel engine, what happens, there is a fuel injector. The left diagram, there is a fuel injector. Through this fuel injector, the fuel injects into the combustion chamber, but there is no spark plug. There is no spark plug, and therefore the combustion has to have happen due to the high compression ratio. Okay, so the compression ratio is designed in diesel engine in such a manner that the auto ignition temperature should be reached for the diesel engine. Once this happens, the droplets which we inject using the fuel injector, these droplets starts combusting. Inside the combustion chamber. So that is called auto ignition. Okay, so there are two main terminologies related to diesel engine and gasoline engine. One is flame propagation, which is related to the gasoline engine, and auto ignition, which is related to the diesel engine. Okay, so the flame propagation phenomena is not possible in diesel engine because of the very poor evaporation characteristics of the diesel fuel. That is why we inject it directly and we use automation technique. Okay, so these are the two basic fundamental differences between diesel and gasoline engine. In one of the engine, in gasoline engine, the combustion happens through the flame propagation phenomena, and in diesel engine, the combustion happens through the auto ignition phenomena. Okay. In gasoline engine, there is a source of ignition. In diesel engine, the source of ignition is there is no source of ignition. Okay, so the ignition happens due to the auto ignition. Okay, 4-stroke engine. This also you must have gone through earlier. So there are 4-stroke engine means when we call 4-stroke engine, it means the piston is basically traveling 4 times from TDC to BDC. In 4-stroke SI engine, you see number 4 is basically this fuel injector. In first diagram, the number 4 is basically the fuel injector. Okay, and that is a low pressure injector, and it is injecting the gasoline fuel before the combustion chamber. Okay, so what happens when the fuel comes here at point 4, it mixes with the air and the mixture enters into the combustion chamber. Finally, the compression happened in the second diagram, and the spark initiated, and then the combustion starts. Flame propagation happen in the diagram. In 3-number diagram, the piston pushes down, piston moves downward, and finally the exhaust stroke. So most of you know, I hope that most of you are already aware about this 4-stroke SI engine. Similarly, what are the different techniques for the, so how the combustion basically happen in SI engine, okay, and CI engine. So the top side in the slide there are two diagrams. One is showing the spark in the spark plug. So that is the spark generation, okay, that is the diagram which is showing the spark generation in the spark plug. Okay, and this spark generation basically acts as the initiation of the combustion phenomena. So once this spark is generated, the fuel air which is in proximity to this spark, the ignition starts with the mixture which is in proximity of this spark, and then this flame starts propagating towards the further portion of the combustion chamber. So this is how the flame propagation phenomena happen. Okay, the second diagram is it does not belong to SI engine. This belongs to the fuel injector. So I am showing this because you should have some comparison between the SI and CI. So in the SI engine, you see the left one showing the spark generation and the combustion is happening because of the spark plug. On the right hand side, there is a fuel injector which injects the fuel in this manner. Okay, so like a flower, and there are very small fuel droplets, diesel fuel droplets, which is spread over the combustion chamber. And due to the auto ignition temperature, it actually starts combustion. Okay. However, in SI, coming back to the SI engine, there are mainly for like 100 years. Okay, after the invention of the SI engine, spark ignition engine, gasoline engine. Okay, for like 100 years, the carburetor system was very popular. Okay, the left one, the left bottommost image showing the carburetor system. Okay, so the carburetor system was very popular for like 100 years. Okay, after the invention of the automobile. In recent time, during the 1990s, due to the stricter emission regulations and increasing pollution level, the technology improved and the manifold injection system was adopted. Okay, so what is the difference between the two? Carburetor system is basically works on the principle of Venturi principle, where the air is flowing through the duct and there is a venturi, and through this venturi, since the pressure drop happen in this venturi, so some of the fuel comes into the channel. So this is how the fuel and air mixes in the carburetor system. However, in this system, the system is not very accurate, and sometimes the more amount of fuel can be inducted into the line, and this is how the fuel loss is there, and also the efficient combustion does not happen in this case. However, in the manifold injection, like you can see on the diagram on the right side, where you can see this, there is an injector number 4. It is showing the injector where the fuel is injecting outside the combustion chamber and mixing with the air, and then inside the combustion chamber there is a spark plug number 6. Okay, and the combustion is happening. Okay, in this kind of injection system, you have very precise control over the fuel injection quantity. Okay, so number 3 is showing the fuel injector. Okay, so the benefit of this manifold injection system is that you have a very precise control of this fuel injection quantity by using the manifold injection system, and that is why this is preferable nowadays. And in almost every gasoline vehicle, whatever you buy, okay, whatever car is available nowadays in the market, okay, this consists manifold injection, because without having this manifold injection, you cannot reach the emission limit. Okay, 4-stroke CI engine. So like I explained, for the SI engine, there was this spark plug on the top. Instead of that, only air enters. For the diagram number 1, you can see only air is entering through the inlet valve into the combustion chamber, and there is a fuel injector. Number 2 is the fuel injector. So in the diagram 2, B, the fuel injector, both the valves are closed and the fuel injector injects the fuel inside the combustion chamber. Through this process, you see when the piston is about to reach the TDC position, auto ignition happen of this fuel because the auto ignition temperature is lower for the diesel fuel compared to the gasoline fuel. So it comparatively, it actually the auto ignition happen quickly compared to gasoline in case of diesel. Okay, so auto ignition happens, and then it pushes. So the auto when as soon as the auto ignition starts, the chemical energy of the fuel starts converting into thermal energy, and it stores as the thermal energy in the form of gases there. Okay, in the combustion chamber. Once this thermal energy, once this compression happen, pressure development is there inside the combustion chamber. It starts pushing. It starts pushing the piston downward. Okay, and this by this method, this thermal energy is finally converting into the mechanical motion of the piston. Okay, this is how the thermal energy is basically converting into mechanical energy. And finally, through the exhaust stroke, the combustion product escapes the combustion chamber and again comes back to the suction stroke. Okay, so this is some representative diagram for the pressure trace. Okay, so this diagram is basically showing the 4-stroke pressure trace result. Okay, in which you can see the blue block is basically showing the suction stroke. Okay, TDC to BDC. And the green block is showing the compression stroke, and the orange block is showing the expansion stroke, and the yellow block is showing the exhaust stroke. So if you look at each of these stroke, then you can see the pressure trace. Okay, so the line which is there is a curve. Okay, that curve is basically showing the in-cylinder pressure. Okay, that curve is showing the in-cylinder pressure. So how the pressure inside the combustion is basically varying, that is how it is happening in this manner. So, and you can see also where the start of injection is happening. Okay, so start of injection and start of combustion, okay, both are different phenomena. Okay, start of injection means when you started the injection of the fuel, and start of combustion, okay, when the combustion will start. And the time difference between the two phenomena is basically known as ignition delay. Sometimes we write it as ID also. Okay, if you draw the corresponding heat release diagram, so you can see that in the lower diagram, this is the typical heat release rate profile. Okay, so the top diagram is basically showing the pressure trace. It means if you measure the in-cylinder pressure in the engine, then this is the typical pressure trace, and the lower diagram is basically showing the heat release rate, that how the energy. So whenever the combustion of fuel is happening inside the combustion chamber, it is not spontaneous. Okay, it takes some time. And there is a rate of heat release. Okay, so the lower profile is basically showing that rate of heat release. So the heat release is not occurring instantaneously. Okay, it takes some time, and therefore in terms of crank angle, you can see that there is a typical profile of this heat release rate. Okay. So diesel. So how the diesel fuel injection system? What are the different diesel fuel injection systems are there? So one is the inline fuel injection system. Second one is the distributor fuel injection system. Okay. So till 1990s, only these two types of fuel injection systems were famous. Okay, inline fuel injection system and distributor fuel injection system. In the inline fuel injection system, you can see that there is a plunger and there is a cam. So when the cam moves, this plunger moves up, and in this manner it compresses the fuel and opens the injector, and the fuel can be injected in the combustion chamber. Okay, similarly for the distributor fuel system, there is again a plunger, but the thing is that there are multiple cam arrangements are there. Okay, so the size of the distributor fuel injection system is comparatively smaller compared to inline fuel injection system. That is the only advantage. However, the other things are same, like the outlet fuel pressure and other things are same in this case. So these two type of inline fuel injection system and distributor fuel injection system, these were famous until Bharat Stage 3 norms. Okay, because the requirement for the Bharat Stage 3 norm, that requirement was the manufacturers were able to fulfill that requirement until it was Bharat Stage 3 norms or 3 norms. Okay, however, beyond Bharat Stage 3, okay, there are certain emission norms which has to be met. Okay, and therefore manufacturer has to adopt the newer technology. So nowadays you will observe in any diesel engine which are satisfying the Bharat Stage 4 or Bharat Stage 6 emission norms. Okay, they are equipped with common rail fuel injection system, CRDI system. Okay, so in the CRDI system is not new technology. Okay, however, it is more costly and more sophisticated technology. So earlier it was not adopted because the manufacturer wanted to reduce the overall cost of the vehicle. Okay, and CRDI system is little bit costly and also and the complicated system compared to the inline and distributor fuel system. Okay, so, but nowadays every diesel manufacturer has to has to adopt this common rail fuel injection system because they have to meet the emission criteria. Okay, so what is common rail fuel injection system? So you can see this layout where you can see there is a low pressure pump, lower bottom most corner, the low pressure pump where the fuel pump is this low pressure pump is basically situated in the fuel tank of the vehicle, and then this sucks the fuel and send it through the filter to the high pressure pump. Okay, there is a metering unit which meters the amount of fuel, and then it comes to the high pressure pump. So the low pressure pump basically compresses the fuel at around 10 bar, and this 10 bar fuel supplies to the high pressure pump, and this high pressure pump compresses the fuel to about 1000 to 1500 bar. Okay, and 1500 bar is too high. Okay, this pressure is very high pressure. Okay, for example, the whatever air pressure we are sustaining over the head, this is approximately 1 bar. Okay, so the high pressure pump generate approximately 1000 to 1000, and nowadays some of the advanced CRDI system generate fuel pressure up to 2000 bar also. Okay, so this pressure, this fuel, high pressure fuel goes to the common rail. On the right hand side, you can see the common rail. Okay, and in this common rail, there are 4 injectors are connected. 4 or more injectors, more number of injectors can also be connected. And these individual injectors normally connected to the engine cylinders. Okay, so in this manner, what we are doing basically, there are 2 major advantages. One is that you are able to inject the fuel at much higher pressure. Okay, beyond 1000 bar pressure, you are able to inject the fuel. In opposite to that, earlier technologies like inline and distributor type of fuel injection system, they were hardly able to inject the fuel at 300 bar. Okay, however, in comparison to that, the CRDI system is capable to inject the fuel at more than 1000 bar. Okay, what is the advantage of having injection at 1000 bar? So this high pressure injection basically automizes the fuel. Okay, and this automation increases the fuel air interaction inside the combustion chamber, and the combustion becomes very efficient. And the metering of the fuel, that when I say metering of the fuel, it means that how much fuel you want to inject. That control and accuracy becomes very good. Okay, so this is the advantage of the CRDI system. And there are various sensors available in order to take the feedback, like pressure control valve, rail pressure sensor, metering unit. Okay, these are the things, and all these sensors are basically connected to a controller. Okay, and this controller communicate with various sensors, and accordingly it gives the feed to the injector or rail pressure, rail control valve, etc. Okay, this controller is nothing but a computer which is pre-programmed. Sometimes we call it engine control unit also. Okay, now this high pressure pump, so you have in this diagram you have seen this high pressure pump. Okay, how this high pressure pump actually works? So you see on the left hand side, this basically shows a typical structure of the high pressure pump, where and this model belongs to the Bosch high pressure pump. Bosch, which is a very well known firm for the manufacture of this high common rail system, okay, fuel injection system. So in this you see there is a cam type of lobe in the center, and there are three plungers surrounding it. So once this central lobe is basically eccentric to the center of the circle. Okay, so because of the eccentricity of this lobe, it actually pushes the piston while it rotates. Okay, and in this manner, the fuel compresses in the above the plunger, and the high pressure fuel can be delivered to the common rail. And this diagram basically showing the common rail system, where you can see the two sensors are there, number 5 and number 2, and number 4 is basically high pressure fuel, which is coming from this high pressure pump, which is shown above. Okay, so from this high pressure pump, the fuel is coming to this number 4 in the lower diagram, and number 6 it belongs. Number 6 is going to the individual injectors. Okay, individual injectors in order to supply the fuel. Number 3 is basically the return line. Return line is provision because if some amount of excess fuel is there, so it can be transferred back to the fuel tank. Okay, so fuel injector. So how the fuel injector is installed inside the diesel engine? So you see there are various parameters by which we actually define the position of the fuel injector inside the combustion chamber. Okay, we can place the fuel injector at certain angle, or also that what is the fuel injection angle, that is called the fuel spray cone angle. Okay, so there are various parameters we need to define before installing the fuel injector inside the combustion chamber. Okay, now nowadays IC engine is not limited to the mechanical devices only. Okay, you must be wondering that there are many components which are electronically controlled in the IC engine. Okay, it is not just the engine or some mechanical components are there. Okay, in the last 15 years, in the last 15 to 10 years, IC engine has changed drastically. Okay, it has changed drastically, and it is basically controlled by an ECU, electronic control unit. Okay, so this electronic control unit is basically the brain of the IC engine. Okay, and this they take feedback from several sensors and give command to many actuators. Okay, so ECU is there in every vehicle. So whenever you open the bonnet of any car, okay, some of you must have car also. So you try to open the bonnet of the car sometime, and if you look into the inside the cabinet, inside the bonnet, okay, so you see that there are many mechanical components. But in addition to that, there are many sensors, many actuators are there. Okay, so and in one of the corner there must be somewhere ECU. Okay, so ECU is hidden somewhere, but there is always ECU nowadays with BS6 norms vehicles. Okay, BS6 and BS4 vehicles, they always consist this ECU, electronic control unit, and it is installed somewhere in the engine. Okay, so what is the function of this ECU? So with rigorous test by the manufacturer, this ECU is actually programmed. Okay, so there are various sensors like speed sensor, or suppose you want in the whenever you press the accelerator pedal. Okay, so what you are actually doing, you are basically changing the position of a potentiometer. Okay, so accelerator pedal nowadays in the car, it is not mechanically linked to any of the mechanical device. Okay, it is basically linked to a potentiometer. So whenever you are pressing the accelerator pedal, basically you are changing the position of a potentiometer, and that potentiometer signal is going to the ECU. Okay, that ECU is nothing but a computer, pre-programmed computer, and according to the pre-programmed mapping, this ECU find out that how much accelerator pedal was pressed. Okay, and according to that feedback, it actually commands to some actuator or the injector, okay, that how much fuel has to be injected into the combustion chamber. Okay, so this is how it works nowadays. 15 years back, most of the vehicles were mechanical. Okay, 15-20 years back, most of the vehicles were mechanical. So steering system was also mechanical, accelerator pedal system was also mechanical. Many things which were all mostly all the systems were mechanical. But in the last 15 years, it has changed drastically because of the increasing emission norms and precise control. And many of the electronic components have been introduced, and those are now essential part of the automobiles. Okay. So electronic control unit. So electronic control unit is basically the IC circuit, and it acts like a brain for the IC engine nowadays. Okay. The details can be, I mean, I can suggest some of the book for reading about the details of this. So this ECU programming is one of the major tasks nowadays, because you have to feed the programming in order to number of tests you conduct in the IC engine. Okay. Now, there are some of the advanced combustion concepts also, which we can go through in brief. So, gasoline direct injection. So, till 2010, only these conventional combustion concepts were famous. One is the SI engine, spark ignition engine, and second one is the compression ignition engine. Okay. However, in late 1990s, research were adopted for the gasoline direct injection technology, also homogeneous charge compression ignition, reactivity controlled combustion ignition, etc. So there are, because of some of the advantage of these technologies. So gasoline direct injection is basically a method where you inject the gasoline directly into the combustion chamber. As I explained, in the carburetor or manifold system, you basically inject the fuel, gasoline fuel, in the manifold, or you mix it in the carburetor. Okay, and then the mixture enters into combustion chamber. But the gasoline direct injection is basically where the injector, a high pressure gasoline injector, is installed in the combustion chamber only. Okay, and only air enters into the combustion chamber, and the gasoline is injected inside the combustion chamber. So there are two types of mode of this gasoline direct injection. One is the homogeneous combustion process, and second one is the stratified charge combustion process. Homogeneous combustion process means the amount of fuel whatever you are in the gasoline engine. In conventional SI engine, the fuel air ratio has to be maintained to the stoichiometric ratio. Okay, I mean, without having the stoichiometric ratio, it means if you do not have proper ratio of fuel and air in the SI engine, the combustion cannot be started. Okay, because of the less concentration of the gasoline in the combustion chamber. Okay, however, in the gasoline direct injection, what we do, the amount of fuel, the fuel air ratio is actually lower. Okay, so whatever fuel is required actually for the required power development, power production, that amount of fuel is only injected in the gasoline direct injection. So homogeneous charge combustion system is one of the technique in the GDI system where fuel is injected with a lower fuel air ratio, but in a homogeneous manner throughout the combustion chamber. While in the stratified charge combustion process, the fuel injected at a certain direction, okay, in a certain direction. In the lower diagram, you can see the fuel is injected in a certain direction, and because of the piston design, because of the specific piston design, you can see there is a deflector in the piston which is actually directing the fuel which is injected in the piston. Okay, that fuel is directed right towards the spark plug. Okay, so this fuel, when it is directed towards the spark plug, the proximity, the space which is closer to the spark plug, that is full of fuel. Okay, that is rich in fuel. So the combustion starts there. Okay. However, then when the flame propagation starts in a later stage of the piston movement, the amount of fuel is less. So in this manner, you generate most of the power when it is required, and towards the end of the piston movement, less power is produced. Okay. So in this manner, the GDI engine is very beneficial in order to have more fuel economy. Okay, so this basically acts like diesel engine also. Diesel. I mean the diesel engine technology, because you are injecting less amount of fuel, but you are getting higher useful power at the end. Okay, so this is the advantage of the gasoline direct injection. Okay, so stratified, when we say stratified charge, okay, it means strata means the layers. Okay, when we say stratified, so basically strata means layers. So in this stratified charge compression, you basically inject the fuel in such a manner that the layers of different concentration of fuel forms inside the combustion chamber. So the useful power can be maximized. Similarly, homogeneous charge compression ignition. So in the gasoline engine, like I explained, the flame propagation phenomena happens. In the diesel engine, due to the auto ignition, it happens. The fuel injection happens, and due to the auto ignition, the combustion happens. Okay. However, in the HCCI engine, it basically very low temperature combustion phenomena is there, and you inject the fuel before it enters the combustion chamber, but at relatively higher compression ratio. Okay, so in this manner, the combustion is more homogeneous in this homogeneous charge compression ignition. The only problem with the HCCI engine is that sometimes you need high load condition. Okay, so this is one of the limitation of the HCCI engine, that the HCCI engine cannot be operated at higher engine load conditions. Okay, so this is very good for the low and medium load engine conditions, but for higher load condition it is not very suitable, and that research is still going on. Reactivity controlled compression ignition. Okay, this is mainly an alternative for the diesel engine. Okay, so you have the conventional diesel engine. Okay, you have the fuel injector, common rail, and diesel injection system. On top of that, you basically install another common rail in the manifold of the engine, the orange color one. Okay, you can see the orange color one, where that is the manifold of the engine, and where you are injecting the E85 ethanol or gasoline fuel. Okay, and based on the reactivity, basically it enters the combustion chamber. So diesel is infamous for particulate and Nox emission. Okay, however, gasoline combustion is very good, and it is only infamous for HC emission. However, if you control it so the particulate control is very difficult, but the gaseous control is relatively easier. So in that sense, the diesel engine generated particulate is very harmful, and it is sometimes difficult to control. However, the gasoline engine generate HC, CO, and NOx, and those are relatively easier to control because those are in gaseous form, and there are devices which are available in order to control those emissions. Okay, so the reactivity controlled combustion is basically the combination of these two concepts. Okay, sometimes we also call a dual fuel injection. Okay, this is basically a dual fuel injection. Okay, where you are injecting two different types of fuels. Okay, so diesel engine, in a conventional diesel engine, whatever fuel injection system is there, that is there. But in addition to that, we install another fuel injection system in the manifold for gasoline-like fuels. Okay, and by having the proper ratio of these two fuels, we can actually optimize the emission level in the tailpipe, and also the combustion phenomena can be optimized. Okay, so that is also one of the research area nowadays, and still people are working on this solution. Fuel injection, okay, in addition to the advanced combustion concept, there are other parameters also which actually control the combustion and emission phenomena in the combustion chamber, and that one of the important parameter is that the design of the injector, okay, how the injector design is done. Okay, so what is the nozzle diameter? On the right hand side, you can see on the left hand side, the lower diagram, you can see the spray, the fuel spray. Okay, it is always desirable to have the smaller droplet of this fuel in the combustion chamber, and in order to achieve that, you have to have the smaller nozzle diameter of the injector. And on the right hand side, you can see the zoomed figure of the injector nozzle, where you can see the orifice. Okay, sometimes we call it orifice also, sometimes we call it injector nozzle and orifice, both are same. And you can see the orifice is in the range, this orifice diameter is in the range of micron size. So the lower the size of this orifice thing, the higher the droplet size will be minimized. Okay, and that will be better for the better mixing. So this injector design is also very important phenomena. Okay, and people do research in this area also. Okay, now pollutant formation and after treatment devices. So you see, basically there are two techniques. I have maybe 10-15 minutes more. So see, till now I explained what are the different combustion phenomena in brief, and how the pollution and the optimized combustion can be achieved by adopting these techniques. Okay, one of the important point is that in the about the discussion what we had till this point, that basically indicates the control of the emission because of this having the in-cylinder modification. Like you want to modify the combustion phenomena, or you want to modify the injector, you want to have the advanced fuel injection system like common rail fuel injection system. Okay, so by adopting all those techniques, you are having some kind of control by modifying the engine devices. Okay, in-cylinder modification, by having some in-cylinder modification, or in and around the combustion chamber modification, you are having some kind of this control over the emission and this thing. Okay, however, in the other there are other things. There as a result of the combustion, there is still a lot of pollutant comes into the tailpipe. Okay, like hydrocarbon emission, CO emission, Nox emission, and particulate emission. Okay, these are the main pollutant components. Okay, and this comes into the tailpipe, and by having the in-cylinder control techniques, still we need some kind of control in the tailpipe also, and therefore we install some kind of devices in the tailpipe. Okay, and these devices are known as after treatment devices. So how the pollutant is basically so you can control the pollutant by adopting two methods. One is that whatever combustion is happening inside the combustion chamber, okay, we can either control, we can either stop the formation or reduce the formation of those pollutants in the combustion chamber, or other option is that let the pollutant form and let it come to the tailpipe, and in the tailpipe we install some device and control it. Okay, we reduce it. Okay, so there are two things, two different phenomena. One is the pollutant formation inside the combustion chamber, and then how these pollutants are basically controlled by using the after treatment devices. So engine emission, you can see that the engine emissions are basically divided into two different categories. One is the regulated emissions, and second one is the unregulated emission. Regulated emission consists CO, HC, NOx, PM. Okay, and these PM can further be divided into CO means carbon monoxide, HC means hydrocarbon, NOx means oxides of nitrogen, PM means particulate matter. Okay, and this particulate matter can further be divided into elemental carbon, organic carbon, trace metals, sulfates, nitrates, etc. Okay, Out of this, the OC, the organic carbon, and the trace metals, these are very well known as carcinogenic, and they cause like cancer kind of disease. Okay, so these are not very good for health. Okay, so therefore there are certain emission regulations in order to limit this CO, HC, NOx, and PM. Okay, so the emission can be minimized. Okay, and this is the basically purpose of having this Bharat stage norms. Okay, so the emission can be minimized. Okay, apart from this regulated emission, there are many unregulated emissions also, and which mainly comes from HC and OC. Okay, hydrocarbon and OC, organic carbon, because hydrocarbon is not a single compound; it is a mixture of different hydrocarbons. Okay, similarly, organic carbon is also a mixture of several different hydrocarbons. Okay. So this also acts as unrelated emission, and this basically results in benzene, toluene, xylene, polyuric hydrocarbon, methane, saturated, unsaturated hydrocarbons, aldehydes, and alcohols, etc. Okay, so these are very harmful and toxic to the human being, and this has to be controlled. Okay, however, there is no regulation to control these emissions till now. Okay, individually these compounds. Okay, exhaust emissions. So these are some of the data which are available with us in the internet. That what is the contribution of automobile sector in the total emission, and how the pollutant formation is happen. So here you can see in the diesel engine, you can see that there are spray. So there is fuel rich region and fuel where the fuel lean region. Okay, so in the rich region there is deficiency of oxygen, and in the lean region there is deficiency of fuel. Okay, between the two spray. So the combustion is not homogeneous. I mean to say that during the combustion, when the combustion is happening, it basically happens where the proper fuel air mixture is available. Okay, so the combustion doesn't start with the core of the spray, or it cannot start with very lean area. Okay, it has to, the combustion starts where the proper fuel air mixture is available. Okay, and the upper diagram basically shows that phenomena. Okay, so the combustion cannot start for the whole fuel whatever you inject instantaneously. So it basically depends on the air fuel local air fuel ratio. Okay, locally available air fuel ratio inside the combustion chamber. So it is not homogeneous combustion; it is basically heterogeneous combustion. In opposite to that, SI engine, it is homogeneous combustion because the fuel air mixture is homogeneous there. So that is why we call diesel combustion as heterogeneous combustion, because the combustion is not happening homogeneously throughout the combustion chamber. Okay, it depends on the local fuel air ratio inside the combustion chamber. Pollutant formation. So the NOx formation is happening because of the mainly three reasons: thermal NOx, fuel NOx, and prompt NOx. Thermal NOx. So whenever the air is entering into the combustion chamber, the nitrogen is also inherently present with the air. Okay, so this nitrogen basically start reacting with the oxygen at very high temperature inside the combustion chamber, and they eventually form NO and NO2. And this is basically the NOx emission. Some of the NOx emission forms due to the impurities of nitrogen present in the fuel, and some of the nitrogen form due to the cyanide radical route during the flame propagation, or mostly during the flame propagation. So this prompt NOx NO is mainly dominating in the gasoline combustion. And composition of diesel particulate. So on the left side you can see the composition, typical composition of the diesel particulate. On the right hand side you can see the artistic view of the diesel particulate, how it looks like. So in the right side, the black portion is basically showing the elemental carbon. The green portion onto the black body, that is the organic carbon. Okay, and there are some like nucleus hydrocarbon, vaporized hydrocarbons are there in the yellow color, and blue ones are basically traces of metals or ash content. Okay, so how the formation of this particulate, diesel particulate? See, diesel particulate is one of the major problem related to the diesel engine. Okay, because whatever black smoke you see coming out of the tailpipe, this black smoke is not gases. Okay, these are basically very tiny small particles which are suspended in the air, okay, or in the exhaust. Okay, these are not gases. Okay, so whatever gaseous emission are coming, you cannot see that. Okay, whatever you are seeing, the black color thing, the black smoke, those are basically very tiny small particles. Okay, and those are called diesel particles, and these particles are very harmful to the human being. Okay, and this is the basically structure of these particles. So these are very small in nano size, in nanometers, and because of their very small size, this actually suspends in the air and makes the color of the exhaust black. Okay, so these particulates can be filtered out by some devices. How the formation takes place of diesel particulate. So there is a certain procedure of this diesel particulate formation inside combustion chamber. So pyrolysis happens, then follows by nucleation, then surface growth, agglomeration, and then finally the oxidation happens. So the mature particle can be formed inside the combustion chamber. Okay, so after that, and the whole diesel particulate phenomenon takes up in a few milliseconds. Pollution formation, so nuclei mode particles, coarse mode particles, and accumulation mode particles. So in the nuclei mode particles, they nucleate accumulation happen and they form accumulation mode particle, and the accumulation mode particle coagulate and they form the coarse mode particles. Okay. So yeah, this is some health discussion like PM 2.5 MT, PM 10. Okay, so it is known that the PM 10 can actually penetrate your nasal cavity. Okay, and PM 2.5 is able to penetrate the respiratory zone. Like alveoli, it can actually cross the alveoli and can enter into the bloodstream. Okay, and it can retain there, these PM 2.5 particles can retain there in your bloodstream, sitting in the cell for some long time, and after some time it actually start mutation in the cells, and this is one of the probable reason for the carcinogenic disease. Okay, so these particulates needs to be controlled. Okay, what particle number emission is another problem, because you see in the advanced injection system there are PM emission has been reduced drastically, but the number emission has been increased. So if you divide one bigger particle into several small particles, so there are two things. One is that the surface area will increase, and second one is that these small particles are basically easily this can easily penetrate into the deeper part of the body. Okay, through the lungs. So these two drawbacks are there with the advanced injection system. Okay, so these are some of the graphs which I would like to skip here. We can discuss it later due to the time constraint. Diesel engine emission and its control. So diesel engine, so like we discussed in gasoline engine and diesel engine. So whatever after treatment devices are there, these are the gaseous emissions are easier to control because of the easily installed emission devices. Okay, however, the particulate is sometimes becomes difficult challenge, and therefore the diesel engine, which is infamous for the particulate emission. Okay, gasoline engine there is hardly any particle emission. Okay, it is primarily comes from the diesel engine. So in the diesel engine, it becomes a challenge sometimes. So we will mainly discuss the after treatment devices for the diesel engine here. So in diesel engine, you see there are main two challenges. One is PM, particulate matter, and NOx, and this can be controlled by the active control systems. Okay, active control system like I explained in the beginning of the slides, like advanced fuel injection system, advanced combustion system, design of the nozzle, injector nozzle. Okay, those are the techniques, and those are known as active techniques, which you are doing basically in and around the engine. Okay. However, there is another technique that is known as passive technique. Passive technique, it means whatever formation is coming out of the engine, let it come to the tailpipe and in the tailpipe we install some of the devices. Those are called after treatment devices, and these after treatment devices can reduce the particulate matter. Okay, so these devices are primarily known as DOC, DPF, SCR, Nox Absorber. DOC is diesel oxidation catalyst, DPF is basically diesel particulate filter, SCR is the selective catalytic reduction, and Nox is the Nox Absorber. Nox Absorber means for NO and NO2. Okay, so these are four famous, these are four popular devices under the passive control technique. Now we will briefly discuss what are these devices, DOC and DPF and SCR, this thing. So how the DOC, so we will start with DOC. So DOC, you see, in the DOC is a very effective in oxidizing the HC and CO emission, hydrocarbon and carbon monoxide, and it basically oxidizes the HC and CO into CO2 and H2O. See, one thing we should always remember that when we talk about internal combustion engine, it is always to have the maximum amount of CO2 and H2O in the tailpipe. Okay, that is the fundamental thing. Okay, why one can say that the CO2 is harmful to the environment, but ice engine experts always prefer to have higher CO2 concentration, as high as possible the CO2 concentration in the exhaust and higher concentration of moisture, because the reason is that if CO2, if whatever HC and CO emission is there, okay, all this CO and HC emission or hydrocarbon fuel, etc., okay, they should convert into CO2. Okay, because if they are released in the environment, if this HC and CO are released in the environment, they are more harmful than the CO2. Okay, however, the overall CO2 should be controlled. Okay, and for that, the engine downsizing is one of the solutions, that we should use the engine with minimum requirement of the power. Okay, so that is one thing. So that is for this. So how the DOC actually works, diesel oxidation works. So when the exhaust comes into the exhaust line, tailpipe, this particles which consist mainly elemental carbon, organic carbon, this passes through the DOC, and whatever OC component is there, organic carbon is there, they oxidize into H2O and CO2. EC is very difficult to oxidize. Elemental carbon is pure carbon, and the reaction of elemental carbon with oxygen is possible only at 600 and beyond, only at 600 or beyond 660 degrees centigrade. Okay, which is not possible in the DOC. So elemental remains there. Okay, however, it is not very harmful, and OC is very harmful. So this is DOC. What is diesel particulate filter? So diesel particulate filter, in the lower diagram you can see, okay, one difference I forgot to tell. This DOC is basically a flow through device. Okay, this is not a filtering device. Okay, it is a flow through device. So there are channels, in the DOC there are channels, and the particles are passing through these channels. There is no filtering mechanism is there. Okay, it is passing through the channel, and because of the presence of some of the very novel catalysts in these channels, this catalyst actually promote the oxidation of OC component into H2O and CO2. Okay, however, there is no filtering happening here. Okay, in addition, in DPF, in diesel particulate filter, in the lower diagram, left hand side or right hand side, you can see that there are alternate channels which are blocked. Okay, which are blocked through the these channels are blocked alternatively. Okay, so the particles which are coming into the device, it has to pass through this perforated surface. Okay, it has to pass through this perforated surface. So gases can pass through this surface, this perforated surface, gases can pass, but the particles cannot. Okay, and particles get trapped into these channels. Okay, so this is how the particles can be filtered out by using the diesel particulate filter. Okay, so this diesel particulate filter is one of the device which is very effective, and it can reduce up to 90%, more than 90% of the particle it can filter out. Okay, selective catalytic reduction. This is basically to control the Nox emission, NO and NO2. this is having four major component. One is the this oxidation catalyst. Okay, so oxidation catalyst basically convert the NO into NO2 and also convert the HC and CO into H2 and CO2. Okay, and then in the second stage there is a urea injection, and after the urea injection there is a hydrolysis catalyst, okay, which converts the urea into ammonia. Okay, in the hydrolysis catalyst, the urea converts into ammonia, and this ammonia passes through the SCR catalyst, where this SCR catalyst this converts in the NO, NO2, and NO into N2, into nitrogen. Nitrogen is not harmful. Okay, and then in this manner the N2 is released in the environment and NO is converted into N2, and after that there is again one small oxidation catalyst which actually converts the remaining ammonia into N2. So this is how the SCR catalyst work, and since because of the huge size of this SCR catalyst, this NOx control device SCR is mainly used in the truck engines. So if you keenly observe the BS6 norm truck engines nowadays, okay, Bharat Benz or some Ashok Leyland, okay, so if it is Bharat 6 truck, okay, Bharat stage 6 compatible truck, then you can see there is a urea tank. I mean, in addition to the fuel tank, there is another tank, that is urea tank. You can see sometime on the road, and that urea is injected in the SCR catalyst. Okay. And however, the SCR is not possible in the smaller engine, so there is alternate for that, and that is called Nox Absorber. So Nox Absorber is a smaller device like DOC, and it acts on the leaner and richer condition, basically the storage and reduction conditions. So when the engine is running under the lean condition, it actually stores the NOx, and when it is running at rich condition, it basically emits the nitrogen and ammonia. If ammonia is released, then this ammonia has to be controlled by a supplementary oxidation catalyst. Okay, I have actually covered the IC engine part, some of the advances in the IC engine, and some of the advances in this emission control devices, after treatment devices. There is one more topic I have, but there is some time limitation, so I would like to stop here, and we can cover this biofuels for IC engine. That is also one of the very major point, but due to the time constraint, I would like to discuss this in some another session. Okay, so we can actually stop here, and maybe we can discuss something if anyone is having some questions.
Thank you so much, sir, for such a novel and mind-broadening session. Now let us move towards the Q&A round. And for this, I will request you all, please ask your queries. You can write it on the chat box also.
Good afternoon, sir.
Yes.
Sir, can we use nanoparticles in a fuel to reduce the harmful emissions, and which type of nanoparticles we should use generally?
I actually, there was some breaking, I mean, in the voice. I heard nanoparticle related some question.
Sir, can we use nanoparticles in a fuel to reduce the harmful emissions, and which type of nanoparticles should we use?
Okay. Yeah, definitely. I mean, see, there are various techniques, and the fuels are basically the petroleum firms already adding some kind of additives already, some nanoparticles. Okay, and not only nanoparticles, but there are many additives also in the form of liquid also. Sometimes they add it. Okay, and nowadays whatever fuel you are getting in the petrol outlet, those are having inherently they are mixed with the 5 to 6% of alcohol. Okay, so the gasoline what you buy in the market nowadays in the petrol outlets, those are already mixed with 5 to 6% of ethanol. Okay, so this ethanol mixing is basically reduces the emission also in the tailpipe. Similarly, nanoparticles are also useful many times, and sometimes this carbon nanoparticles or in the form of graphite or something like that. So those are very useful sometimes, but there are many other nanoparticles are also available. Okay, I don't remember the exact name of those nanoparticles, but sometime I have gone through this nanoparticle research also in several research papers where they have used the nanoparticle for controlling the emissions. Okay, but you can find in the Science Direct or some other research portal, you can find ample number of these research articles based on this nanoparticle, using the nanoparticle to control the emissions. Okay, that is not my core area, but yes, of course I know that there are a lot of research going on in that area also. Hello.
Thank you, sir. There is one more question from Mr. Manish Sahu. He's asking, what are the differences between BS4 and BS6 and why there's a huge price difference between them?
Yes, yes. Okay. So, for example, I just showed this DPF and DOC. Okay. So, I purchased my car with BS4 compliance. Okay, I have a car and which is BS4 norms, which is fulfilling the BS4 norms. Okay, and it has the DOC only. It has diesel oxidation catalyst only. Okay, sorry, it has oxidation catalyst only for the gasoline engine, not the diesel oxidation catalyst. So there is some difference between the diesel oxidation catalyst and normal oxidation catalyst for the gasoline engine. So it is having one oxidation catalyst. Okay, one BS4 engine, and BS6 engine is also having some kind of advanced this emission control technique like DPF. Suppose a truck is coming in the market. Okay, so if you buy a truck in 2014, which is BS4 compliance, okay, that is having only diesel oxidation catalyst. Okay, and in 2020, if you buy some truck that is having BS6 compliance. So according to the BS6 compliance, there are basically these limits. Okay, you have to meet. So there are this particulate. What is the particle concentration in the tailpipe? Okay, and what is the CO concentration in the tailpipe? So that limit has been drastically reduced. Okay, so in order to meet that limit, we have to control these emission levels more rigorously. When I say more rigorously, you have to control this emission. It means that you have to install more amount of these devices. Okay, so for 2020 truck models, in addition to DOC, you have the DPF also. In addition to DOC, you have the DPF also, diesel particulate filter also. When you are adding an extra component in the vehicle, okay, obviously it is going to cost you more. Okay, so this DPF and DOC, these are normally coated with some noble metals like platinum, palladium, and rhodium, such kind of elements. Okay, so when you use these devices, the cost of the vehicle actually increases. Okay, because these devices cost a lot. For example, a simple diesel oxidation catalyst costs you approximately 50,000 to 60,000 rupees in a normal sedan car. Okay, so if you are going to fix the DPF also in that car, then again it will increase the cost of the vehicle by 70,000, 80,000 rupees. Okay, because DPF is costlier than the DOC. Okay, so that is one of the reasons that the BS6 vehicles are costlier than the BS4 vehicles. Does that answer your question?
Yes, sir. Yes, sir.
Okay. Okay, there are
Very good afternoon to you, sir.
There are other okay. Somebody is asking for email ID, so it is Pravesh @itbhilai.ac.in. It is available in the website also. Thank you, sir, for the nice session. Thank you, sir. We will share the PPT on the.
Yes, sir.
Thank you so much.
Thank you so much. We would like to convey our heartiest thanks to Dr. Pravesh Shukla, sir, for such an exciting session. That was a supreme paradigm of why this kind of interaction is crucial. We are very thankful for enlightening us.
Okay, thank you.
Thank you,
Thank
sir.
you all of you for attending the session.